So this is the last slide we had yesterday. We're going to finish the review of Chapter 8 today and dive into Chapter 10. So I dug up some FAA practice questions. Here you are. Okay, I see you at 9:07 a.m. Thank you. So let's see. I gotta figure out a better system to harass students. Let's see. Somebody. James, it is your day to get harassed, at least for the next 5 minutes. So, do you have any thoughts about what the best answer here is? You took the fuel control unit off. You put a different one on it. You removed and replaced it. Now the FAA is saying that one of these three answers is better than the other two. So let's go. Perform a full power engine run. You think you're going to do a full power engine run? Make sure that the engine puts out the maximum amount of power that it's supposed to? Let me ask you this question. If you're flying in the aircraft on takeoff, do you need the engine to put out 100% of its horsepower or thrust that it was designed to? Pardon me? In fact, just say absolutely for sure. What if the engine only puts out 90% of its power? How long of a runway will the thing take? Will it take the normal amount of runway, or will it take more or less? Probably more. So the pilot, or whoever's calculating takeoff performance, is calculating that performance based on the engine is going to produce takeoff power. So we're going to do a full power engine run to see if it produces full power? You think that's a good idea? Okay, that's a good idea. Now it says to check the fuel flow. So you think we're going to check fuel flow? You think we're going to look at a gauge that says how much fuel is going into the engine? Think we're going to look at that gauge? I know you've done a lot of jet engine run-ups, so this is an easy question for you. Say yes. Yeah, very good, James. Okay, so I've seen them on APUs, but other turbine engines I've ever looked at, inside the cockpit is a gauge, and it says either how many gallons per hour the engine is burning or how many pounds per hour of fuel that the engine is burning. And normally, that engine, if it's producing takeoff power, it's also burning a certain amount of fuel per hour, and there's normally a correlation between that. So that A sounds like a pretty good idea to me. How about letter B? You know what a fuel nozzle is? Okay. Inside the engine. We've already put the engine together. It's installed on the aircraft. Are we going to be able to recalibrate the fuel nozzles after after the engine's still in the aircraft? No. So I don't like letter B is one of the good answers. No. In this test, I would draw a line through that answer to keep me from even thinking about it anymore. So how about letter C? We talked about this yesterday. Do you know what trimming is? Or trimming? Changing the shape. Yeah, you can put, in the old days, they actually put the exhaust pipe to change the area of the exhaust pipe. People don't do that much anymore. They just change power settings. Pardon me? No. Can you tell me what trimming is? Question. Is that Parker factor and you do better under pressure? If you take out the fact of what you're actually physically doing, what is trimming? It's pretty thing as changing, yeah. Changing what? Anybody want to help James? It's very similar to rigging. In fact, you could argue that trimming and rigging overlap. Generally, rigging is the basic, get all the controls to move in the right spot, and then take the aircraft outside, estimates. Make sure that the engine puts out takeoff power, and stuff like that. So does that help? Okay, so does C, yeah, control, you removed and replaced it. You think you need to retrim the engine? You would think so or you would not? No, why don't you think so? What are the three things if you disturb or remove what, or what? Does anybody want to help James out there for those three things? The propeller, if you remove and replace them, rig it, but for the definitions for you, trim adjustment and trimming, and you run the engine. Fuel control unit, some adjustments with the engine is running. Yeah, okay. So do you like letter C? So now we're stuck. Now we have to do this game called which is the answer he wants me to know. That's where you buy $40 worrying about what the right answer is, and you just memorize the FA answers because you don't really care. Oh wait, that's just me. However, let's look at this very carefully. If we look at letter A, James, perform a full power engine run to check fuel flow. If you're going to do a full power engine, were you going to check anything else in addition to fuel flow? Would you make sure the temperature of the engine wasn't too hot? Would you make sure the oil pressure was good? Would you make sure it ran at idle RPM? So there's a lot more than just checking fuel flow. So me personally, I don't like A as much as, because if you do letter C, if you're going to retrim the engine, you're effectively going to check everything, not just fuel flow. Yes. Yes. Yeah, that's a very good point on there. A is really included in letter C. So, James, based on Mr. Johnson's discussion over the last 4 minutes, which of these is he going to mark correct? C. And if I was going to answer in Spanish, I would say C, that is correct. Not even a chuckle. Okay, fine. All right. I got to find something else. Here, this rope is really prime and ready to go. Let's see. Pardon? David, how you doing? That's my younger brother. Yeah. Yeah, you know. Yeah, he has a beard, usually. He's grayer. He's like in his early 50s. So there's, and he wears glasses. He doesn't have as good a suntan as you have. In any case, David, what should be done initially when the turbine engine catches fire when starting? How many times have you started a jet engine? So do you know a lot about jet engine starting? Okay, we're going to cover a lot more about jet engine starting between now and the end of the semester, because we're going to cover how to. But we did talk about fire being a hazard. So just don't look at that for a second. Look over this way. All right. If you wanted to put out a fire, can you name one way to put out a fire? Okay. What if you don't have a fire extinguisher? What's the next best way to put out a fire? I would not pee on it. Maybe on a campfire. I know. Is this your first semester, David? Okay, all right. So I can harass you a little bit more. So the three things you need to have a fire. You got to have three things. Don't worry, we didn't cover it this semester in this class. I mean, I don't mind if you look. It's not there. If you took a log, a piece of wood or a piece of paper into outer space and tried to light it on fire, would it catch on fire? No. Have you ever taken a piece of wood or paper into space and tried to catch it on fire? No, but you know that it's on fire? You're pretty sure? You're pretty sure? If you take a piece of wood or a piece of paper out into space and you try to catch on fire, I agree with you. No oxygen. Okay, so of the three things you need for a fire, can you name one of them? Oxygen. Okay, great. So, I'm going to put this finger down next. What are you worried about? I'm going to go in order, clockwise on the way. What else do you need for fire? What did we take in space and we tried to catch it on fire? We tried to catch a piece of paper or wood or something. Yeah, so another way things on fire besides paper and wood. Have their eyebrows. On fire? Johnson, I don't have to talk about that. I'm just kidding, David. Surely you don't have sealed court records because of arson. Say no, Mr. Johnson, I don't, and please stop calling me Shirley. All right, I got one person to laugh at the Shirley joke. So you need something else. You need oxygen, and you need the thing that's going to burn. Yeah, Elizabeth, her name's not Jade. Say the word fuel. And then what's that one? Heat. Yeah. Did I tell you that? It would. Okay, good. Because if he did, I'd tell you to keep him behind in the seat. Yeah, you need oxygen, you need fuel, and you need heat. So if you want to stop a fire, you just need to stop one of those three, or stop more than one. So if we don't have a fire extinguisher, and fire extinguishers tend to get in the way of the oxygen, although if you use water as a fire extinguisher, that can cool things down and remove the heat. Let's just say it's an engine fire and fuel is leaking out of the engine. How could you stop that fuel from burning anymore? Turn off the fuel. Man, David, you're awesome. That is exactly right. You could turn off the fuel. So here's the question. Do you turn off the fuel, squirt it in the engine, or do you turn it off farther towards the aircraft before it gets to the engine compartment? Yeah, I wanted to turn off the fuel shut so fuel couldn't even get to the engine compartment, because that's a different place to shut off fuel than just inside of the engine. Okay, so now let's try this. Okay, David, you still with me? All right. Don't worry. If you need, Wyatt in the backside with your foot, he can handle it. So turn off the fuel and continue engine rotation with the starter. Okay, fuel. Do you know why it says continue the engine rotation with the starter? Okay, well then let me ask you a question that you may have learned in Mr. Asim's class this semester. Going through the core of the engine, aspect, and the main core going through there gets burned up, and how much of it goes through there just to cool the inside of the engine? Does it all get burned up? Okay, well let me ask you this question. All the air that goes through the engine core, is it get burned up in the combustion process? Not all of it used to, other than burning. Some of that air does what? It cools the inside of the engine. So, if there was an okay, how could we by running it? Yeah. Okay. But take those outside engine. So if you add an exhaust gas temperature, you can see it. Gas temperature goes down. is it's blowing cold air, taking some. You like it? Answer number one? I mean, letter A? Okay, let's look at B. New engine start rotation. Does that sound good? Will that help cool the engine? If we, just the first half of letter B. Continue engine start rotation. Do you think it's a good idea to keep rotating the engine? You can say yes, no, or maybe. Okay, maybe. All right, I'll accept that answer. And discharge a fire extinguisher into the intake. You're shaking your head no a little tiny bit. I can think of two reasons why shaking your head no. Has anybody fire extinguisher? Yeah. Okay. How about the dry powder? Ever fire extinguisher is David? Never in it, but it blows kind of like baking soda. Okay. Do that into the engine intake. Where would all this powder end up? Would you say to engine on the inside? What? Yeah, you'd have to overhaul it. You take it all apart, clean it correctly, because you don't. Two fire extinguisher. Has pretty. What temperature is it? It's really cold. So we've got this really hot engine part. Cold air. So that is that metal. If it's cool it down really fast. Happens to the size of a piece of metal if you heat it up. It doesn't change its size very much. Have you ever taken a torch? Do they expand, or do they contract, or do they stay the same size? Expand. Okay. So if we cool it, we've got this 1,000 degrees something. It's really cool. What? Take a piece of glass out of the refrigerator, crack it, warm it up. What might happen to the glass? It might shrink, and going to crack. Same thing happens with these. Heat them. Heating them up fast is usually okay, but cooling them down really, really fast, they're. If we use a CO2 fire extinguisher, damage the engine parts. We damage the engine parts. So what? To find out which ones are damaged. Yeah, we're going to tear down the engine. We're going to have to take. Want that? Okay. So can you see why shoving a fire extinguisher into the engine is engine apart and fix it? Then, unless I had to, or human life, screw that engine. Goodbye, engine. Hello, somebody's life, especially if it's mine. So would you do that for me? If you have to destroy a jet engine to save my life, you promise to do that? Okay, all right. They can garnish my wages for $10 million until I'm 375 years old. That'll be fine. Okay, so do you like into the intake? Oh, okay. All right, let's look at C. Continue starting attempt. Of course, attempt, say just motor engine. So I'm wondering if it also keeps squirting fuel in there. No, I don't know. In order to blow out the fire. Here's a problem. If you aren't standing next to the engine, do you know if the fire is on the inside of the engine or on the outside of the engine? Well, if you're not looking at it, let's say you're in a big old jet airplane, just side of the engine. It's possible, unless the fire is in front of where in back of where the temperature gauges are. Yeah, it might be difficult to know exactly where, but point out the fire. I got a question for you, David. You're very harassed you for this whole question. I really appreciate it. If you get frustrated, just kick the person in front of you. Your aggressions in a politically correct, socially acceptable manner. Sorry. Engine fires. If it's a carburetor fire, generally with piston engines, you tend to pull the mixture control out, but keep cranking the engine to pull the fire into the engine. So the FAA gets you here. Oh yeah, on reciprocating engines, if it's a fuel fire in the carburetor or the engine, cranking, keep cranking. Pull the flames into the engine, because the inside of the engine, it's okay to have flames. So the problem I don't like with C is it says continue starting it. It doesn't really. David? Yeah. Does answer C say anything about turning off the fuel? So do you think C is the worst answer, the best answer, or right in the middle? I think it's the worst too. So if it was me and I was taking this test and I could write on it, I would run along or C, so I would stop thinking. Yeah. A and B, which do you like? Because it says turn off the fuel. Yeah, I like it. And how about the second half of B? Do you like discharging fire extinguisher engine intakes? Not generally, no. Okay. What's the name of the gentleman that sits behind you? I'm sorry. Hey, Rick. Good morning. That's right. When this class is over, it's exactly half over. Does that sound correct, Richard? Today, 10 o'clock. We'll be halfway done with A. That'll be halfway done on Wednesday. Wednesday, the halfway mark is the middle of Wednesday. Well, 3 hours in the morning, 3 hours in the afternoon. If you don't count 10-minute breaks, don't worry. However you describe it, I will make sure I figure out how you're wrong and I am correct. Richard, which of the following can inspect and approve a major repair for return to service? How many semesters have you been here, Richard? 3. Okay. Probably somewhere in. Is this your 3rd semester? Okay, so probably you had paperwork and mechanic privileges. So it means I can do a very high level. So, I'm happy if you just question. Mechanic. Major. Repair. You not only have to have a mechanic, you have to have an extra authorization. It's called it's called being an authorized inspector, or it's called having an inspection authorization. So does anybody, well, I got to keep harassing you because it's your question, Richard. G-R-L-Y. Okay, so Richard, which of these answers sounds good to you? C. Yeah, since it's a pair and it's on an end. Well, look at number 1. Could they do minor repairs on engines for letter A? How about letter B? All they have is a power plant rating. Can they do minor repairs on engines? It's an engine. They have a power plant rating on their mechanics. Yeah, the answer is yes. They could do minor repairs. But the question is major. So you're correct. To have an AMT mechanic, you got to have a mechanic certificate, and you have to have an inspection authorization. Let's see. Somebody in the last row. Oscar. I'm sorry I remembered your name. So, Oscar. What semester are you in? First. Okay, so you won't know any of this. Okay, so that means anything. Are you ready? Okay, all right. FAA publications and their FAA regulations. The question is, what publications? It's a minor repair. That's three is the regulation where it says this is how to do maintenance. This is how what you have when you make a tree that you did something to an aircraft or an engine. This right down. Or made. Not help you. An AC and did the opposite, you would need to have a really, really good reason to do it. It's one of the lowest ones. I'm going to go back. Let's see, where was I? Major or minor FAA regulations. Okay. So, does it describe what's a minor repair? Be happy if you knew it was in 40, even if you didn't memorize the appendix. This row. What's your name? Jacob. Hi, Jacob. What semester is it? Second. Okay, so moderate harassment. So can you describe a class A, B, C, D, E, F, G, H, I, or J type fire? I can't either because they don't go up to J. They don't go up to letter E. You know, if E is for live electrical fires. There's a K, I believe. Fortunately for us right now, Jacob? Okay, sweet. I remembered your name for 35 seconds. Do you know what class A, B, or C fire? You said you didn't know. Okay. Let's start with the letter A. If you were walking around somebody's house, not your shop, but you're walking around a house, what's the most flammable people's houses? The wood. Class A is A. Fabric that would burn. Arguably, solid. It's not a liquid or a gas. That's pretty common. If you peel that plastic lamination off the top, piece of doing the plastic, heating it up into solid. But then it starts getting kind of gooey, and then you start wondering whether it's a liquid, but we're not going to go there. So class B. So, Jacob, now let's do the shop here. Tell me anything that's flammable out here in mechanic school shop. Gasoline, engine oil, liquids. Okay, so class fires and extinguishers that put out class B are flammable liquids. Flammable liquids. So, do you spend more time at home or more time in lab, in shop? At home, you're probably asleep some of that time. I'm guessing, you know. Okay, all right. So A is most common, B is less common. So C, what? Jacob? Flammable gas. Yeah. So that is farts. That would be a class C fire. If a cow, giant fart, and it's that gas is flammable. Or if a break in a natural gas pipeline, or you turn on your gas stove but it doesn't light, and the gases are coming out, and then it catches on fire, that's a class C fire. That's of these three. Live electrical is letter echo. Pardon me? Don't worry, I'm writing the test. C is electrical? Well, then you and I looked on a different place. Because I have C as gases. I will class B fire. Thanks, Wyatt. I'm going to look that up. Well, I Googled it. I couldn't remember what C was. Let's see. Alentino, how are you today? You were doing, I called your name? I have to answer that question. What semester are you in? First, woohoo! All right, so you have a lot of experience with aircraft bonding jumpers. That's where you get out on bail from a bail bondsman, and then you jump bail. I know that's pretty. Ever gotten bail from a bail bondsman? Okay, I've done that like count how many times I've done that. But I've almost never jumped bail and gone to another state. Of course, that is why I'm not living in Arizona, but that's a whole other story we can talk about. Thanks, Wyatt. So a bonding jumper, I want to make sure I read this and I thought there's a couple of good answers here, and then I read more. A bonding jumper, let's talk about a reciprocating engine. You do an engine overhaul in Mr. Zucchi's class? Okay. When you put an engine onto an aircraft, the engine has a starter motor bolted to it most of the time, right? Okay, but there's only one big cable going to the starter motor, and that's positive. How does that starter motor get connected to the negative side of the battery? Have you thought about it a lot? Okay, well then it's a good thing we're here today so you can think about it. Have you ever worked on a car? Have you ever put a battery into a car? You ever notice where does the negative side of the battery go on a car? It gets connected to what? To what? To the body of the car. Yeah, it gets connected to the metal of the car. Same thing in aircraft. The negative side of the battery gets electrically connected through a cable to the airframe, if the airframe is made out of metal or aluminum or steel, which is most of them. Okay, so if the negative side of the battery is connected to the metal of the aircraft, and the starter motor is metal and the engine is metal, what do we need to do to the starter motor or to the engine to make sure that it's connected to the negative side of the battery? We would need to connect them together. So what when you put an engine, whether it's a turbine into an aircraft, you're going to bolt it. One of the things you're going to do is a metal strap. It might be copper or aluminum or steel, and you're going to bolt it to the metal of the engine, and then you're going to run and bolt it to the airframe, the metal of the airframe. So the engine is connected to the airframe, and the airframe is electrically connected to the negative side of the battery. If we bolt a starter onto the engine, and it's metal contact, is the starter motor electrically touching the engine? I guess, yes it is. If the engine has a strap going from the engine to the airframe, is the engine connected to the airframe? Yes, okay, so is the starter through the engine connected to the airframe? Yes, okay, so the starter's connected to the airframe. And the airframe is connected to what side of the battery? Try again, the airframe is connected to what side of the battery? Try again, the airframe is connected to what side of the battery? Is connected to the airframe, and the airframe's connected to the. So how is the starter connected to the negative side of the battery? Yeah, all those connections. You need the positive wire, big positive wire going to the starter, because the metal of the starter is connected to the engine, which through a strap is connected to the airframe, and from the airframe is connected to the negative side of the battery. So the engine. Okay, all right, sorry. Thanks for letting me drag you through all the time. So, okay, jumper is a wire that makes sure that two things are electrically connected to each other. So if I take and I run a plastic rod, then I'll have two. I can reach over and get, and it'll shock you because you don't have very many electrons jump across that little 1/8-inch gap, a little tiny lightning. If I had a wire, you or between the and you, go through the wire and get to you. When I tried to touch you with the rod, there wouldn't be any extra electrons because I've grounded or I've bonded that rod to you, so I can't have too many electrons here and not enough on you. Making any sense? I know I don't have a plastic rod and a silk piece of fabric. Sorry. Well, I have some silk underwear at home, but that's a whole other discussion. Bond connect pieces of material so that electrons can go back and forth all they want on one side versus the other. Does that make an electrical conductor? Electrons go through electrical conductors are just wires, just a fancy name. So a bonding jumper is really just an electrical wire. So let's look at letter A. If engines are do the engine go a little? You ever look inside of a car and somebody jumps on the throttle and the engine kind of twists a little? You ever notice that? Because the engine mounts, they have rubber in them. Same thing when you take that engine and you put a reciprocating engine into an airplane or a helicopter, there's rubber engine mounts. Run that engine, the engine twists a little bit. So, do you think that bonding needs to be able to flex? Do you think it needs to be flexible? Is it going to have to move a little? If it's connected. Even a little? A little bit. Okay, so it has to be at least a little bit flexible. So, answer A here says bonding jumpers are not subjected to flexing. So do you think this is a good answer? I agree with you. So I'd probably put a little X over it, think, I don't think I like that one. So let's B. Provide a low electrical resistance to the ground circuit. Now the ground circuit is the airframe. So we have a bonding wire stuck from, it's an engine, and we've got that bonding wire to the airframe. Can the engine have too many electrons on it? Or are they going to go through that wire to the airframe if they want to? The ground. Can the electrons go through that wire if they want to? If there's too many electrons on the engine, some of them go to the frame. Yes. Okay. All right. So a low electrical resistance. You know the difference between a high electrical resistance and a low electrical resistance? Be careful, because I heard you out there with Mr. Asman at the beginning of the semester making you guys run around tables. Resistance for electrons to go through it, or hard? Try again. Well, low electrical resistance is not. Can you have electricity going through it? Well, try again. Okay, low resistance. That's like a big wire. Has low resistance. Can a lot of electricity go through a big wire? Okay, so low resistance, can electricity go through it easy? Okay, so B says a low electrical resistance. So do we want this wire to allow electrons to go from the engine to the air really easy? An engine and an air between them. And we get too many electrons on the engine. Do we want some of them to be able to go through that wire to the airframe? Yes, we do. Okay. We want them to move easy. Big wires, do they have low electrical resistance or high resistance? A big wire, does that allow electricity to go through it easy or allow it to make it really hard? It's really easy. So easy electron flow is low. If we had letter B, low electrical resistance, would that allow electrons to move? B look pretty good? It looks pretty good. Okay, so let's look at C. Prevent buildup of a static electrical charge between the airframe and the surrounding atmosphere. So have you had that semester on radios yet? Alentino? Am I saying that right? Alentino? I bet you haven't had that semester. So there's no way for you to know what the answer is. But I want you to know the answer. So let's say you got an airplane, you're flying along. And as you fly through the air, and air goes across the airframe, some of the electrons are going to stick to the airplane. So the airframe will have too many electrons on it. And that means you end up having an electric field around the airplane. And when you try to use the radio waves can't get out and the radio waves can't get in. So we got to get rid of these extra electrons. So literally, if this is the wing, you're going to put a discharge wick there. And that discharge wick is designed so when the air goes across it, the electrons that are the negative electrons on the airframe will leave the airplane and go into the wind. So instead of getting all these electrons, they disappear, or the electrons leave the aircraft, and you get rid of the static electrical charge. So when it says this answer right here, where it says airframe in the surrounding atmosphere, it's talking about the static electrical discharge wicks that are out on the wing of the airplane or the tail. Sometimes they put them on the tail of the airplane. But that's not a bonding jumper. Bonding jumper is that wire like between the engine and the airframe. So this is a discharge wick. So does this sound like a bonding jumper, David? No, it isn't. So do you like answer C? You don't like answer C? You don't like answer C. Did you like answer A? I don't like it either. Okay, I agree with you. I would have chosen answer B. Yeah, you doing okay, David? No, the other David. Oh, sorry. Hey, David. How you doing? Sorry. Alentino. Am I still saying that right? You're the first Alentino. I used to work at Valentino's Pizza. Have you ever been to Valentino's Pizza in Reedley? Yeah, okay. Well, that's how I made money to buy cigarettes and beer and take flying lessons. Not necessarily in that order. Okay, that's enough for one.